Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello, so we're here at GOTO Amsterdam 2023 in a sunny Amsterdam, Netherlands. And I'm here to do a GOTO Unscripted. So I'm Matt Turner from Tetrate, and I'm going to be talking to Daniel Bryant. Welcome, Daniel.
Thanks, Matt. Hi, everyone. I'm Daniel Bryant. I'm an independent consultant at the moment, having worked with Ambassador Labs for a number of years before, and looking forward to chatting with my buddy, Matt.
Yeah, thanks, Dan. So I'm a software engineer at Tetrate. I guess this is a broad software engineering conference. So just to step back for the folks who don't know, I guess, both of our backgrounds is sort of cloud native stuff, the more cloudy, modern side of the tech. And we will be probably talking mostly about infrastructure.
Sounds
kind
good.
of things, I imagine. Just to level set for folks, but this isn't going to be like a React.
Yes, that's a really good point.
Kind of chat, I guess. Yeah. It is unscripted. We really haven't unscripted it.
Yes.
Really haven't scripted it at all.
We have got interesting conversations all the time, Matt. So I'm just thinking.
I feel like we do. Yeah, this time we're sober. So this might even make sense. No, I mean, we literally just came out the back of your talk here, which obviously folks can see on the website when it goes live, which I thought was really good, really interesting.
Appreciate it.
I like the way you set the stage and sort of stepped back and said, why are we talking about all of this technology? What is it? And where does it fit into your organization? What's your organization trying to do? What's it trying to achieve? I know it's unscripted. I am technically meant to be interviewing you, which means you do more talking than me, which is good. I don't know, can I stitch you up right at the start and say, like, what is an API gateway? Let's talk about that topic for a bit.
Yeah, it's a great question then, because someone actually at the end of the talk asked about, like, is an Nginx in front of my microservice an API gateway? And I was like, yes, it's a good question. And I probably should have defined it a bit clearer actually in the talk, because I think, like, both you and I have worked in this space for a long time, Matt, right? And an API gateway means many things to many people. And really for me, it is just like where you're doing your traffic management, particularly your north-south traffic management, your ingress traffic management. And I think over the years, an API gateway used to be very focused on APIs. Sounds obvious, but now I definitely think folks in some ways are like, I'm just mapping routes, or, I'm just exposing ports and like whatever protocol, right? But I think the history is around actually the API management space. So people were like actually creating, say, REST APIs in particular. We've been seeing some, protocol buff and all that kind of stuff, but mainly REST APIs, like back in the day, like sort of the SOAP era. And people were like, this actually is really critical to the business, and therefore I need to manage this thing. And it was like, where do we manage it? Well, where the traffic's flowing in. And that's like the API management, and it's a gateway. API gateway was kind of born. But I think these days, like we see in the Kubernetes land, like people even call Nginx an API gateway. And like initially, like I resisted that because I was like, Nginx is a proxy, right? Like, just routes traffic, right? But I was like, no, I kind of get it. Like you are putting APIs at the edge of your system, and you are like controlling the access with Nginx, actually a proxy. Istio these days will like pick, take your pick, right? And like even Istio as a service mesh has an API gateway, sort of a gateway, at least component, right? Yeah. So I think it means many things to many folks. And this is sort of one part of the time, or one time I should say, where I'm not too hung up on the terminology. You and I have talked about this before. Like sometimes terminology and words matter a lot, right? And I think they still do. Like I wouldn't call something that's like obviously not an API gateway an API gateway, but I was more concerned today with saying to folks, if you're managing cloud native traffic, like you're going to be using something that is an API gateway to get user traffic into your backend systems. There'll be other things involved, service mesh, which is very much your expertise, Matt, CNI, SDN, that kind of stuff. But the API gateway is where the rubber meets the road, where the users hit the backend systems, right?
Yes. Yeah, I think for me, the word management does a lot of lifting there, right? Because why do you even need to manage it? And I think to your point that you made in your talk is that people smear business logic into that, just like they did with ESBs, just like they did with aspects in aspect-oriented programming, just like they did into utility classes. We've seen this before, and we've all done it. And I've smeared logic into the API gateway as well. What do you even need to manage if your API is if the system serving your API is perfect, then maybe it could just be a router. Maybe it is just a layer 4 device, right? That is just a tunnel. But realistically, you probably want some extra security, like a WAF. You want bot blocking. You want load shedding. Yep. If you've got a fat gRPC server and a service mesh in front of that, and you can do all of these things, a proxy, a sidecar proxy that can do OIDC challenges, then maybe you don't need it. But I think that's what we often tend to mean by management. And then you do get more into I want to publish an API to this thing. Yes, as in I'm going to give you a schema, a version schema, hopefully with a schema for the body. Yep. And, please reject, please fail fast and, reject requests that come in too quickly, reject requests that don't meet my body. Yeah, totally. Or please transform body version 1 to body version 2. Oh, okay, fine. Please patch this error in the program because it was quicker to reconfigure the API gateway than reconfigure the server.
So that with Log4j on that.
Well, right? I was about to say, I think that's where we hit an anti-pattern, right? Because that's business logic. But actually, we helped a lot of folks at Tetrate, have to do a plug. We helped a lot of folks mitigate Log4j because you could match the headers and the bodies, and it was really quick to, if you have sidecars, then you can do it there as well. So we did both, but why not drop it at the edge too? Yeah. And I think that's where the gateway API comes in, because you've got a unified management, API, unified control plane for both components. But management does a lot of heavy lifting as a word. But I think I agree. To me, it's a proxy with features.
I like that, yes. Because on one talk I did, I actually had almost like a spectrum, right? And I had like that sort of classic, Nginx, OpenRest, DHA proxy, Envoy proxy, all the way through to Apogee 3-scale, like heavyweight kind of business stuff, right? And then you could somewhere on that spectrum pick where your API gateway is, right?
Right, it's like, do I have no features? Did I just download, say, Envoy? Yep. Do I have the open source features in terms of a bit of rate limiting or something? That's right. I have the paid for features that folks are starting to add, like advanced bot blocking or schema.
Security, observability, like API management.
That's what's critical.
Pay money for that, right?
It's critical. It's what you need it if you're regulated. So folks, to your capitalism point, folks do take the opportunity to make money off that, but also it's the high value stuff. It's the stuff that takes a lot of engineering work for the companies to build. So I think, it's the kind of thing where you would make a build decision even if there was a dollar cost attached to it, a buy decision, if there was a dollar cost attached rather than a build decision.
Because actually directly translating to the value you would offer as a business, right? Or what cost you would incur.
Higher costs you would incur because it's a difficult thing to engineer. Yeah, interesting.
Something you touched on, Matt, which I thought was curious there, is we talk a lot about ingress with API gateways, right? But you mentioned an example with the Log4Shell, Log4j issue. That was a lot about egress, right? In terms of scanning stuff as it was leaving the environment. So I think that's something interesting with API gateways. A lot of folks focus on the ingress, but you can also look at sort of what's egressing from your systems there as well, right? I don't know if you've got an experience around sort of observability in that regard, or even things like security. I know a bunch of folks have been chatting online around, in particular, data exfiltration, things like that, right? Either I guess you can do it at the service mesh kind of level or the sidecar level, but you can also do it at the API gateway level. I mean, did you see that with the whole Log4Shell stuff? Were you deliberately patching and looking at payloads coming back through the gateways or through the sidecars?
We saw folks who wanted to. It's difficult. I think there's a lot going on there. So a naive network doesn't have any kind of proxy, right? It's layer 3. Let's say I've got one VM offering a service, one container offering a service. I give it a publicly routable IP. It's now on the internet. Requests come in, requests go out. Yeah. Probably not great. So the first thing I do, zero trust is a whole other thing, but the first thing I do is isolate it in some way. Yep. So maybe it still has a publicly routable IP and I've got a sidecar that's doing MTLS and is doing the zero trust thing. Or more traditionally, I would put it in an isolated network. I would, make those, I put it on a VPC. Makes sense. Subnet that's unroutable and I put a proxy in the way and that's the way to get it. So that thing can do extra, checks. They're kind of the same if you squinted them in the right way, right? So then I have that ingress, and then that ingress I upgrade to an API gateway by adding these kind of features like, I want to filter headers or bodies for the JNDI, whatever string. Yeah. But I think another level of sophistication, is egress management. I mean, you go to any big enterprise, anybody that's regulated, you'll see there'll be DLP, right? Yes. Data loss prevention. And you're right. What's that other than an appliance, a pizza box that you rack and stack? All egress traffic has to go through it, and it tries to look for documents to say, company confidential, or they do more than that, but you get the idea. So we do see folks doing this, not going to that level, but doing this with Istio. The obvious thing is that I just want to firewall everything, right? So I want to allow list, no egress is allowed.
Oh, interesting.
Because why?
So locked down by default.
So locked down by default, and then I want to allow list. Oh, this, we use weather.com to provide whatever service, we use, because a lot of stuff is now third-party online APIs, right? So we use weather.com and some mapping service, some postcode, zip code to address translation APIs.
Right,
PayPal API is probably a better example. So you can allow list those one by one, and then with something like a service mesh, you can actually get more sophisticated and allow list them service by service. So this service has reason to be talking. Right. And the reason I would say a service mesh is because you can't really do that by source IP, but once you've got a strong identity for every service,
love it. Yep.
You force the way you do it with Istio is you would force traffic through, you set up an egress gateway.
Yes.
Force traffic through it. So if anyone managed to sort of bypass their sidecar or break out of the CNI or something, there's no egress from by security group, right? By really low level construct. There's no egress from this network other than through the egress gateway. And then you can start allow listing things like that and say, hey, the orders service gets to talk to the PayPal API, the Stripe API, the stock prediction service talks to weather.com or whatever it is. Did we see anybody trying to block like egress for Log4Shell? Not that I can remember, but if you have that allow listing, deny by default approach, then I guess you'll kind of do it. I don't remember anybody.
I think maybe
trying to match.
But I think we're seeing on the internet people were sort of saying this is a quick filter for these kind of things.
Absolutely. Well, I did a KubeCon talk with a good friend of mine, Francesco Beltramini from Control Plane. We did that in Amsterdam, and we were talking about incident response, security incident response, and how it varies in a cloud native environment. And one of the things we said was, you've got a lot more tech now. You've got You've got a lot more options. So actually, if you think you're on, because you can't prevent every attack, and actually you often want to know quite a lot about if you are under attack, especially if it's targeted at you want to be able to learn quite a lot about it. So what we were saying is, if you think you're under attack, or if you've got a pod or workload that you think is compromised because, Falco's saying it's making weird syscalls or something, then actually you may want to let that attack continue, but you want to watch the egress. So you want to see where it's connecting to, what DNS request it's doing, what IPs it's connecting to. Can you find its C2 network, basically? And then what is going out? Does this look like IRC traffic? Does it look like some kind of C2 command and control thing? Does it look like your data being exfilled? In which case, you probably want to stop away pretty quickly, right? But we see it. You'd see it as an interesting observability point and an interesting, as you say, a place to do defense in depth. It's difficult. Like if you ever get your home router and just deny all. Yeah, right. You'd be it's a good security stance to have, and I'll just open. I know I won't say the names because people's devices will go off at home, but I know this smart speaker is probably going to talk to its services, and I'll open things one by one, and then if you've got some kind of way of doing identity, my phone, my laptop should be allowed to browse the internet, but maybe I carve out if you've got a sophisticated home router, I carve out a separate subnet. A separate SSID for all the smart home things, all the bulbs you buy off eBay. And you say, I'm going to block all, and they've all got web servers in them. Right? And not only do I want to block ingress because they've all got web servers in, and that's a massive security hole, I want to block egress because what do they do? Why are they dialing home? They just don't need to. You'd be surprised how much breaks and how much you have to open to get functionality back for these devices. It's kind of scary.
That's like we were saying earlier on, just in general, the plethora of technology gets emerged is amazing. You and I make our living out of it, right? But at the same time, the complexity is shot through the roof. I was sort of trying to hint at that some of my talk today. And that's a great example in terms of I think most of us are just did it at home, we're just whatever, allow all. But in a business, you can't do that, right?
Do that. Right. And that gave me a real appreciation for the sort of security compliance teams I've worked in a couple of regulated places, and you just think they really do have to allow list everything.
That's why you and I build stuff rather than do security, right?
Well, it's interesting.
It's a super important job, but I'm it drives me nuts.
Well, and that's why you need to get the dev experience right and whatever. And maybe we'll come on to that. But it's interesting you talk about platform engineering, and you talk about things getting super complicated and trying to hint at that. And I think this is my point of view on the platform engineering. Is you talked a lot about cognitive load, and cognitive load on teams, app development teams, just gets so high. And I think we saw it get high trying to write everything in C and having to write your own linked list, right? So we invented Java, and then it got high again when folks had to do their own deployment. You build it, you run it, but deployments, especially canary deployments, progressive delivery, again, something we might come on to, that got super complicated. So we built them platforms, API gateways, and all these kind of things. And I think now their cognitive load on just infrastructure. I just want to operate this thing, debug it. It needs a bit of storage. It needs some DNS records. It needs traffic management, east to west. I need observability. That all gets so complicated. And I think that's where we're seeing platform engineering really coming into its own. If you subscribe to the team topologies model, right, and you have a platform team that's enabling.
Yes.
What are your, I've put a bunch of words in my own mouth there, but I mean, what's your opinion on platform engineering, on the self-service thing? What is you build it, you run it? Because we say you build it, you run it, but then we say actually you should have a platform engineering team. Like, how does that all fall out in your opinion?
Yeah, I think someone asked me the other day about sort of like platform engineering and DevOps and things. And I think a lot of us have been doing platform engineering before we had a word for it or phrase for it. Do you know what I mean? Like, you and I've probably been building platforms. I used to rack and stack back in the day, and that was kind of platform engineering, right? But these days, there is many more components within a typical platform. Back in the day, it was like rack and stack a server. You put like a Java app server on it, maybe front it with a like web server or something, and that's kind of happy days, right? And the attack vector, attack surface was pretty small because you kind of knew those bits of kit and whatever. Whereas these days, we're spinning up virtual environments and, the notion of self-service now is no longer that racking and stacking. It is calling APIs, calling SDKs. And I think the modern definition of platform engineering is around how we build the ultimate platform that developers, operators use to get their day job done, how we build that platform so they can self-serve on things like being able to spin up a new service, being able to deploy a service, as you mentioned, being able to monitor that service. So all the kind of machinery around that process for me is the sort of discipline of platform engineering. Do you know what I mean? And I think, and now like just with the sheer complexity out there, it is a really valuable discipline, particularly in big companies. Like I think, sort of some ops teams, some infrastructure teams are somewhat being rebranded as platform engineering teams, but I think they are also bringing in new skills. Like you came up to me at the end of my talk and went, team topologies. And I was like, I didn't mention it explicitly, but totally right, Matt. Right?
See the straight of it, yeah.
And a lot of folks I'm chatting to, and granted it is like somewhat biased with like either customers or folks at conferences, but they have read that book. Like team topologies blew the kind of doors off like the way people build products, right? Build platforms. So people are really now thinking about that cognitive load and almost chasing the holy grail of like the Heroku-like experience, or the Cloud Foundry experience. That was kind of the pinnacle, right? Like even more so than racking and stacking and putting an app server on something. Like Heroku for me was like as close as we can get to perfection of like Ruby on Rails apps in particular. Right. You know what I mean? Standard form factor, 12-factor apps. Yep. They work for stateless to some degree as well. But like it was Nirvana for a while, right? I was loving it.
The amount of Kubernetes teams, DevOps teams using Kubernetes that you just see trying to rebuild Heroku. Or folks going all in on AWS or whatever, just trying to rebuild Heroku. And that's not a bad thing, there's a reason for that. It's interesting you talk about standardization of all the apps looking the same from the outside. When it was Ruby, you had Rails, so you had the sort of standard, everything was the same because you used the same framework. That's it. Everything kind of quacked everything was operationalized the same. That's not bad grammar, but you know what I mean? Everything ran the same because of the 12-factor thing. Yep. I think containers were what let us do that across different languages, right? Because everything now looks the same from the outside. Everything runs the same. Everything fits into the same, hole when we deploy it. But we still need the rest of the Heroku experience. That's it. Based on top of it. I think it's interesting because we talk about self-serve. To me, I think there's two things that platform teams do. One is to chop off the layers, right? Because there's so many layers. Now, I'm talking literally, power, physical security, data centers, all the way up through clusters and networking and stuff. And for a long time, I've talked to CTOs who's like, my job is to chop layers off the stack, off the stack.
That's good enough. Yeah.
And, so now maybe AWS takes a lot of the, deals with the power bill and whatever. And then you manage cluster even, and then you have a platform team that abstracts more layers. But then the self-service to me is there's always going to be one layer where we have to meet, because you build it, you run it. It's like you run it at this layer of abstraction. So maybe we do give you kubectl access, and maybe you do write CRDs, or maybe you run it within the abstraction that we've built. So one of those layers is going to be like, I think the app team should only ever be interfacing with the top layer if they have to care about lower layers.
Makes sense.
You've probably not built an abstraction right. And there's always going to be collaboration to me at that layer. That's what we mean by actually self-service. Is maybe they can have that layer all to themselves, but realistically they probably can't. So there's going to be two sets of folks trying to work there.
Yeah, something I really like that kind of like chopping the stack, because I've seen lots of diagrams of like how containers have allowed us to do that, and then Amazon Managed Services. Something you just mentioned there, like, I think the notion of mechanical sympathy is really important. And it kind of nicely gels with what you're saying, in that as an app developer, I actually just want to like put something in a container and run it, and I want to be able to like monitor things. But if I understand one level down, mechanical sympathy, like I know it's going to be running in a container, I know it's going to be ultimately on Kubernetes, and I sort of have an idea of the pod abstractions, or maybe even how the VMs work, how the networks work at a very basic level, I can build more effective systems. So I think that's why I've seen some struggles recently of like, to your point, I've seen every abstraction leaks, right? Just the way it is. And people are like, hey, I'm deploying on Kubernetes here, even though the platform team's tried to hide it, right? Right. They know it.
No, this is,
actually, that's not a bad thing. Because like, if you completely abstracted Kubernetes away, some of the things that they see happening would like not make as much sense as when they know it's actually Kubernetes. So it's a fine line, right?
That's interesting. And it's so much work. It would be so much work for the app team. It would be so much work for the app team to learn the whole stack.
Yes. Exactly.
Cognitive load can't be done, but it's also so much work for the platform team to hide all of those things and to make a perfect Heroku.
Yeah.
So I think you have to choose which abstractions you expose, which ones you allow to leak. But I think the mechanical sympathy things were really interesting, actually. Maybe there's a layer in our diagram where the app team gets to play. Either they own it completely, ideally, or they interact. But understanding the one below them, because a lot of my talks that are successful, some folks do big ideas talks, right? The kind of things that I often do are just like explainers.
Your Istio one always stood out to me. When I was scaling to Istio, I went to Code Node in the UK in London, and you're like, this is how Istio, this is how a packet goes through Istio. And I was like, I get it.
Right. And should you need to know that as a user of Istio?
Yeah, good point.
And it's interesting, like this is crystallized in my mind, because you always get imposter syndrome, right? I certainly always get imposter syndrome.
Sure.
And I would stand up on stage and try to justify the talk, especially when I've been invited to the conference.
Yeah,
and
it makes sense.
Often, that talk did fairly well. It became fairly famous. And I get invited to these conferences that weren't even infrastructure engineering conferences. Right. They'd be like a software conference or something. It'd be a bunch of Java devs. And I would feel the need to explain myself and say why I'm here. And like, okay, well, you need to know this, because if it breaks, you're going to have to debug it. So you're going to need to understand how it works. But actually, no, I think you're right. I think what we're teaching is a lot of what I've found myself doing is teaching folks the layer below.
That's it.
And that's really interesting. Even on the good day. So they understand it. They have a mental model for it. And it's not just the debugging. Like you drive a car, right? You just drive a car, it breaks, you call someone. I'm sure there's a great analogy in here, is you could just have breakdown cover. Like anything goes wrong.
That's the SRE team.
It's the SRE team, very expensive.
Yes.
Or you could learn how the car works, and A, you can have a go at fixing it yourself. Right. But B, it's that mechanical sympathy. If I will drive it in a way such that maybe it won't break.
Totally.
And if I hear this noise, then I know that that's a bit of stress on this component. I'm going to change the way I do things. That's a very interesting way.
I like that. So that's it. Martin Thompson, who's spoken at GOTO a number of times, like it sort of crystallized for me. He was doing a lot of talks around mechanical sympathy, and he goes properly down to the metal, right? He was like using Java in ways it shouldn't be used. It's fantastic, right? And as like you and I kind of like, as a 1%ers, we always like to know everything pretty much, right? That's kind of who we are, and that's why we go to conferences. But like, not everyone wants to know that, not everyone needs to know that, and that's totally fine. I'm not trying to use the 1% as like some elitist term, but I think you and I are always poking into this stuff. So when Martin Thompson started saying, here's what mechanical sympathy was, like I would never be building systems that he was going to build, but I was fascinated in the way he'd use some of the unsafe Java stuff that made me understand the Java memory model better. And I could write Java code better knowing the memory model, right? And I was like, and that's that one level down, the little cracks sort of showed through in the abstraction. And I was never going to use some stuff. I wouldn't trust myself, right? Stuff. But I was like, wow, like I get how the heap works better. Oh, and that's why you got to be careful with the stack and that kind of stuff. So just like having, and your analogy is perfect in terms of like, peeking down into the containers or like with the car, like knowing how to, when to change gear most appropriately.
Right, exactly.
And the power bands and like not revving to the red line every time because you're going to break your engine.
Right? Yeah, exactly. You've got it when you need it. And I always find those talks super interesting as well. I've never really done much Java. I was initially an embedded C programmer. You had to kind of know your architecture to get acceptable performance. And now I love Rust.
Yeah.
And you see these talks. You're like, hey, Rust, we're just going to turn the safeties off, essentially. Right? We could turn the traction control off. You can do that in a car as long as you actually know how to drive one to the next level. If it starts to slide, there's no system. it's only safe to do that if I know what to do.
Yes.
Right. And I think it's the same. Like in terms of safety is off in Rust. And if I actually understand my processor and its memory pipeline and its cache invalidation and all of this stuff, it's safe to do that. And you always see every conference, there'll be some high frequency trading house who do a fascinating talk, right?
Yeah.
Where they're like, oh yeah, we 10x our performance by just, like we know how the pipeline works. We just tell the thing not to flush it because we know we're being safe.
Yeah.
And it's just always
That's
fascinating.
Formula One racing, right?
Yeah, exactly.
Most of us go to the shops, like
stuff.
I'm driving my little like CR, whatever.
Right.
Don't need like.
But it's fascinating to hear about.
It is.
But I think every day. But we all do probably need to know at least how a container works, and
I think that's like that, and that's what I tried to like hint at today. And like you and I have had many like talks over the years and presentations around this. Is I like to do, I don't go perhaps as deep as you, but in my talks, I do like to get people thinking, just even asking the right questions, right? Like in terms of, because like the sidecar model was quite revolutionary for a lot of folks, but like I've been using similar patterns for quite some time, right? But you wouldn't like, your talk was like, how the packet flows through Istio. People are like, sidecar, I see. This is why I get certain security guarantees in terms of like, I'm over a local network versus like, global network, whatever. And I think, that's something I've seen a lot of good conference speakers do, is just make people think a little bit, right? In terms of, because I like to be pushed sometimes. Like to your point about, I'm never going to be building Rust stuff, but I find that stuff fascinating. Right. And often a lot of what you learn is transferable somewhere else. Like a lot of what I learned in C is transferable to Java, and Java, like even to the ops world. Like we talked today in the talk around coupling and cohesion. Like that's all up and down the stack. Right? High coupling can be at infrastructure, can be at the application level, all these things. So I just love, like, my advice to folks that are new is like, learn as much as you can.
Yeah,
right?
I would
and you'll see the
agree.
patterns emerge.
And the big patterns, learn as much in adjacent, but also just step right back. Every time I see Kubernetes, right? Especially in the early days, I was like, it's the actor model, I've done it. I've done Elixir, this is the actor model. It's great, sure. But when we can now do actors with languages that don't have actor frameworks, right? And I think a lot of those analogies really, really work. You talked about developer experience. There was actually a really good audience question, I think. Is that not just user? They were. Yeah. Is that not just user experience? Yes. Like, because developers are users, and you were saying you should have a product mindset and a product manager and whatever. Do you think developer experience is a solved problem now? To me, there was a step change with Docker. Like, the technology is great, but one of the main reasons I think containers took off is Docker over LXC or whatever came before. It was just so easy to use.
Agreed.
And we now have all these TUI frameworks, and you can get super shiny, colorful. I'm a terminal person, right? You can get terminal stuff. Also, to your point, it's not stupid if it works. That don't look down on people who use UIs and all of this stuff. Do you think enough effort has been put in that we now can't make things even easy to use, or are we still on that journey?
Oh, great framing. I'd say we definitely are paying a lot more attention to developer experience than we were like 5-10 years ago. I think the Docker example, I use that all the time, is a perfect example. Docker gave us good developer experience and a centralized hub to store stuff. That was game changing at the time. I think a lot of the products we use day in, day out do have developer experience at the forefront. You even argue some of the Kubernetes stuff, like kubectl is pretty well engineered, right?
Right.
Like,
I was going to say, that was one of my examples. kubectl explain. You don't get that in, well, okay, actually you do get it in Vim. That's not really a good analogy, but yeah.
But some of that, I remember and again, I'm put disappointing fun at Amazon. It's mainly because I've used them the most. But I remember in the early days of Amazon Cloud CLI, I was lost, right? And every command, because Amazon famously build all their technology sort of separately, right? And as long as you integrate an API, it's fine. But I learned the command one way to do stuff, and then I go to a different part of AWS and be all different. And whereas once I've learned kubectl, get entity, get resource, you're kind of good to go, right? So I think a lot of the things we use day in, day out, it's been really well thought about. But the kind of pitch I made today is I think the tools I see people building internally do not have the care and attention applied. And I can speak from personal experience. Like when I used to build tools, I'm like, it'll be fine. I know it's a bit wonky around how you configure this stuff, or I know you've got to spin up like a local binary and make sure you've got the latest JDK installed, whatever, right? Do you know what I mean? Like you still go, But then that actually contributes to bad developer experience. Because I know Java, I'm happy installing a JDK on my machine or a JRE, right? And then the Ruby person next to me is like, I don't really want to install a JRE. And I'm like, tough luck. But I'm like, that's not a good developer experience, right? So I think a lot of the stuff, it's permeated the open source space, and CNCF I think have done a fantastic job with that to a lot of the degree there. It's Docker led the way, other folks like that as well. But I don't think it's fully permeated the rest of the world. You know what I mean?
No, that's a good point. You step out of our cloud native bubble, certainly.
Yes.
Again, we should probably be mindful of the audience here. Within cloud native, I think Docker was the step change. You now look at kubectl or something being super good. But you step outside of that. And you do get, and I think, there were some technology changes as well. So the ability of to package something as a container.
Yep.
And Go, and of course Rust.
Yes.
The ability to make a statically compiled binary.
Yeah.
It sounds silly, right? But like, it's just like you don't have to install a JVM. You don't have to use PYVM or whatever it's called, RVM.
Yeah,
There's
right.
none of that messing around.
Yeah.
You can just use it. You can just get a statically binary. I mean, you can obviously wrap Java with a jar. I think you can get
You can actually build like native
you
like
can
images.
you always could get self-executing jars, wars, but
That's
they were
like Spring Boot
huge.
popularized that, yeah.
But they were huge, right? Whereas Go, it'll be, if you don't have much business logic, it's 5 or 6 meg.
I couldn't believe it when I started playing around with
Right.
Go stuff. I'm like, and I love Spring Boot, so I love Java ecosystem, but like 200 meg minimal kind of thing.
Right.
I mean, that's what I was
This makes it
thing. I was
tractable.
tiny.
Yeah.
Yeah, it's interesting, isn't it? Like I don't know. I'd like to get your take, Matt. Like, have you played with Wasm very much?
Yeah,
I think,
they do.
like, so obviously
Yeah.
coming back from the sort of the old school Java days, the write once, run anywhere was a thing, right? And it's sort of like the joke was write once, debug everywhere. You used to say, right? Because it never quite worked.
Elite abstractions.
Yeah, that's it, right? And where they weren't quite implemented, standard across the frameworks and across the platforms. But I bumped into Wasm a lot with the Envoy stuff, with like extensions, things like that. But I saw a couple of great talks in KubeCon New York a couple of weeks ago, talking about Wasm being maybe the sort of ultimate format for building that binary. And this great talk was from the Cosmonic folks and the Fermion folks.
Yeah.
And they were talking a lot about WebAssembly components. How you can, like, say, reuse a Rust library in a Go app, something like that.
Yeah.
And it just got me thinking, like, wow, like, to your point, like, Go was a game changer. Scratch container, Go binary.
Yeah.
Revolutionized the attack surface, the runtime requirements, many things, right? But I wonder, what's your take on Wasm? Do you think that is the next evolution of where we're going? Because we can compile many languages to a Wasm target, right? But like, I'd love to get your take on that.
It's a really good question. I really like it. I wish it the best. I hope it works. I think this has always been a great idea, and there's never been an implementation that, as you say, has been quite right. I'm going to be that old man again and say, we've done this before. So LLVM, actually, there's a really great blog out there. I'd have to dig out the link for it. It'll take a while, but there's a really great blog explaining like what LLVM, it wasn't just trying to be another C compiler. Obviously, GCC had its issues, but it was trying to be so much more than that. And it had this whole idea of it transliterated everything into this intermediate representation, and then of the front end, this abstract syntax tree of the front end, and it transformed that to a bytecode, essentially, and then it would compile the bytecode to machine code. And that was the architecture of the compiler, and that let them do compilation of C and C++ better than GCC ever could, because GCC just sort of amalgamated over time. But they had all the tooling that you could take that bytecode, and you didn't have to compile it in the compile phase and then ship the machine code. You could ship the bytecode. It would then ahead of time compile on the target machine. So you could ship the bytecode anywhere, and you would just run it in a little runtime, but it wasn't really a runtime because it would ahead of time compile it. It would just do that. It was like, I don't know where I'm going to deploy this. Here's your LLVM bytecode. Oh, it's this machine. Or even this is the whole like Gen 2 Linux philosophy, right? Like, I know it's going to be an AMD 64 laptop. Oh, but it's this specific Intel model, so I can actually like turn on all the processor features and get the optimizations. This is what, because they were C folks, this was the lens I think they were looking at it with. Deep. But there was also like, I don't know if it ever got out of experimental stage, but there was a just-in-time compiler as well. So anyway, LLVM bytecode tried to be this universal format for packaging software and shipping software and interoperability between languages, because you could have a bunch of front ends. They were all compiled together. Like Java, again, it works pretty well. I can have a Scala class and a Kotlin class and Java class, and it does work. Like, it does work pretty well. Like, trying to call the Scala from the Java because of all this like symbol mangling and stuff, but it's sort of just about tried to work. So LLVM tried to do it before, and it just never took off. I really hope Wasm will be that thing with things like Wasm Time and Wasmer, and I can they're a lightweight runtime, so I can now essentially /run. I can get a bit of Wasm bytecode as a command line binary, and I can kind of /run it. I can run it server side so Fermion is essentially
the paths for Wasm for what I've heard, isn't it?
Yeah, or maybe I'm thinking of it. Yes, there's a particular tech. I think Docker can do it natively now. So instead of giving you an OCI container containing machine code, I can now just give you a Wasm bundle, so I can run that as a container. I get the same. We still set up namespaces and C groups, but I don't fork a process. I just run a Wasm runtime, and so I can use it as a packaging format like that, and I can also use Wasm to embed code in other code for extensions, like you were talking about API gateway extensions, right? Yeah, right. Envoy, Envoy gateway, Istio is totally extensible by Wasm. If you're in Golang, which is the cloud native language of choice, I can compile Golang to Wasm it works. It's not perfect. But then I can write Go and I can embed it in a C++ program or anything else that hosts Wasm. And conversely, if I've got a Go program, I can use the Wasm library by Tetrate. For open source, but full disclosure. Well, more like a full disclosure, it's open source. And then I can write TypeScript or whatever, compile that to Wasm and edit. So you've got that interoperability in every direction. I mean, I always do a demo with Istio showing how extensible it is. And a lot of folks do this. And one of my colleagues does it with, a screen's worth of TypeScript, compile it, you add a feature to Envoy. I do exactly the same thing, but with a screen's worth of Rust. Compile it, and it just works. So I really, it seems to work well. It has the performance characteristics. Folks have thought about the developer experience and the packaging and the how we run it, how we operationalize it. And it ticks all the boxes of proper server-side code, including running natively and running well in a orchestration environment, not technically even containerized, of embedding in other processes and extending things, like a Spring Boot module framework or like an ESB, but hopefully done better. And I can also make command line programs as well. So how long before we get, I think if we ever see a Wasm coprocessor, then Wasm instructions, then, because remember we're going completely off topic here. This is just historical apocrypha. The Giselle extensions to ARM. So ARM processors had, like an AVX or an SSE, they had an extension, they had a set of instructions that was basically a hardware implementation of JVM operators, some of them. So they could run Java in an accelerated way by basically saying, this is so ubiquitous, what we're going to give you hardware acceleration for this. Now, it wasn't all of them, because the JVM bytecode is a very high level thing. Like it assumes that it's memory managed. There's a one op for like virtual dispatch, right? It's all very Wasm. It's like a CISC architecture. Wasm is very low level. It doesn't model things like a virtual dispatch. But I think as a result, it probably makes it much more amenable to being implemented. I'm making this up. I don't actually read about this yet. But I think if we ever see that, that's probably a
we are seeing that drive towards specialization, right? But even like ASICs, that kind of stuff, right?
Yes, if I could get an FPGA but yes. Sorry, very long-winded answer. But I am in favor of Wasm. I think we've seen the pattern before, but I think the dev experience and the operationalization of this is just coming together in a much better way.
I suppose we are going a bit off topic, but it's super interesting in that something, so I'd almost forgot about the LLVM stuff, but I remember that we covered it a lot, InfoQ and QCon, there's a big furore, but I never saw a community develop around that. And that's one thing I'm seeing a little bit around Wasm, like as a community, right? And it's even like you and I sort of the cloud native era, right? And I think the community built around like the CNCF in particular, got to give them another shout out. But like as we're building platforms, there is a community around these platforms. I wonder if like there's going to be sub-communities around Wasm, and if there is that then like that, is that the driver that's finally needed? Because I do think, like to your point around like dialing back to API gateways, if we can write extensions modules in whatever language we're comfortable with and compile it down to Wasm, it will get rid of that kind of like dodgy like Lewis script type stuff that I'm sure we've all written, right? Do you know what I mean? So I'm wondering, like, is the community, I guess is my loaded question there, is the community the thing that makes or breaks this?
I feel like it probably is. I think you need a critical mass. And if you have a critical mass, a community probably emerges. It's probably always going to emerge. Unless your critical mass is defense or research institutions or one of these folks where you see these texts and they don't, you do have communities around Slurm or something like HPC orchestrator within, defense and academia and CERN, but I feel like it never really breaks out. But I think
it's a very tight community or very well-funded community.
Exactly. But with no incentives to, because they're well-funded, maybe with no incentives to go out and reach out to help from other folks. But I think we are seeing a community insofar as there's multiple compiler projects, there's multiple runtimes on the back end. There's at least one runtime. And there is now the CNCF, again, shout out to them to sort of hopefully help bring all these folks to make conferences and host projects and provide test infrastructure. So I would hope so. Maybe that is the difference. I don't know why that LLVM stuff didn't get the critical mass.
No, you definitely sparked the memory. I remember having many discussions with it. I can't remember that time frame, but then disappeared, right? And then Wasm popped up on my radar, particularly around some of the Envoy Wasm stuff I was looking at the time, and I was like, and the dream of being able to write any language to compile down an extension, I was like, yes, this sounds very interesting. And now I am just seeing more of this community emerge. But I think to your point, time will tell, right?
Right. And that's why I do my examples in Rust is because it's the anti-Lua. Like, you probably want to write TypeScript or Zig or something, like, realistically, but I'm going to show you it can be done in like a hardcore language.
Yeah, interesting.
Because, and if you do run this in a tight loop, you are going to get good performance because it's just so far removed from Lua, which I'm not a fan of.
Yeah, I've had to learn Lua like several times for various extensions, but like, not a fan.
Right. I should give you the opportunity to talk about your book, which is just, I have to confess I haven't read it.
I'll get you a copy. We're good.
Okay, we'll do this again and I'll come better informed. Do you want to tell me, by proxy everybody else, what is the thesis of this book?
Yeah, so we started actually just as the pandemic emerged. So it's been quite a therapeutic project for myself, Jim Goff and Matt Alban, like with the three of us came together. It's focused on mastering API architecture. That's the title, right? And actually it was born in New York, February 2020. So just as the pandemic was unfortunately emerging, myself, Jim and Matt had been to a Riley Software Architecture Conference, and they were talking about API gateways, so was I, and we realized that, something what we see in a lot of conferences, that the knowledge that we thought was kind of like obvious was not obvious at all. It's like common sense, anything but common, right? Do you know what I mean? And like, when we were like saying, hey, like you clearly need to think about extensibility of gateways, or you think about security posture. And there's a lot of people saying, this is great knowledge. Could you go a bit deeper? We were like, interesting. We kind of struck a bit of a seam of gold as we're chipping away there, right? So, we reached out to O'Reilly and pitched them, and they said, API architecture is a hot topic at the moment. So along with cloud native and Kubernetes was like super popular, and we were like, we can cover all those things, right? Mm-hmm. So it turned, the title is Mastering API Architecture, but it turned into a kind of cloud native communication book, if you like. So we talked a lot about how you would migrate from like the traditional world into the cloud and using sort of the API as the lens of how to do that. Do you know what I mean? Because we see a lot of folks doing digital transformations, and they're often like that word is super overloaded, to be honest, but those words are super overloaded, but oftentimes they're being API driven, like their business is moving to offering some of their services via an API, that kind of thing, and they're often moving to the cloud and they're embracing DevOps principles. So like all those things that, were mentioned there are often tied into how you manage your APIs, how you manage your cloud native communications. So the book literally covers like soup to nuts all the way through. We talk about sort of like some of the high level concepts around designing APIs, like thinking about REST versus protobuf or gRPC versus GraphQL, like sort of mixing my metaphors there or mashing up the different levels. But we get people thinking about these are your options, these are the trade-offs you're going to be making. And then we talk about testing. I wrote the chapters around the API gateway, naturally, right? And the service mesh, naturally. So like we're sort of getting people thinking about how to go around evaluating their technology solutions and choices. And then towards the end of the book, we talk a lot about migration. So migrating towards an API architecture or a somewhat like a microservice. We tried to avoid that word quite a lot in the book because like Sam Newman has got that one covered. He's done a fantastic job, right? And we didn't want to write Sam's book again because he's done 2 or 3 amazing books. So we sort of said it's service oriented with an API that commonly is microservices these days. And then we talked about the migration towards that, migration towards cloud tech. And then we did try and get a couple of chapters in there around security. Because like you and I are constantly talking about the importance of security, right? And I would be honest and say as a developer, when I first started out, didn't think so much about security or performance, right? Yeah. And then as my career progressed, I totally did. So we're trying to put that on people's radar. Think about the illities. Think about the security, the observability, the performance, that kind of stuff. And good feedback so far. We launched it in, I think, November last year. So we've got the hard copies around then. The journey has just begun. Like once you put a book out there, then you get all the feedback. And you're an idiot. You're brilliant. Like,
V2 will be perfect.
That's it.
Exactly. Like every piece of software I write, version 2 will be absolutely flawless.
We're totally like looking at that. So we're thinking of doing some like training courses and stuff. Because obviously the world is now opening back up. We didn't have the first book I wrote. I created a whole bunch of like other material with my buddy Abraham. I wrote it with Abraham Perez. We did sort of like, we promoted it and shared more knowledge where the world opening up around the whole release of mastering API architecture has like meant it's been a bit more challenging getting the word out there. So thank you. Appreciate you asking me about it because I'm keen to obviously get it out there.
I think it's a great topic. Well, I mean, of course, and I'm happy to. But I think it's a great topic and I actually wanted to learn a little about it as well. I've given a talk, not at GOTO, or have I given the talk yet? Maybe I've just written it. Anyway, on essentially, because you say that you think this knowledge is common, and I find it isn't. I joined a company once, like really good actually. Everyone in the team was really good, like everybody was super high quality. but they knew their area. And I kind of turned up and I built them. I used the buff tooling, which I really like.
Oh, yeah.
I won't put you on your spot. I know you're in this area. I won't put you on your spot for your opinion on anything because you still got to play in that sandbox. But I personally really like the buff tooling. And I kind of built them this whole thing where, folks would write, there was a repo, you would do interface-driven design, like we used to in a good monolith, but you would write, would write your, contract-driven design, whatever you wanted to call it. You would say, I want to do this microservice. Okay, show me the API design. You use Proto or Open API, but you just had to give some kind of IDL spec for it. That would go past all the principal engineers or whatever. We'd sign it off. And then you check that in, and then a whole lot of machinery would kick in, mostly using the buff stuff. And you'd end up in a schema registry so that other folks could find it and say, there's that service being offered. And these are the methods on it. Yeah. Here's how I call it. Some of them are REST, some of them were RPC. Again, we were agnostic to that, but here's how I interact with it. And then the machinery would just go build you a bunch of libraries, right? A bunch of client libraries for it. Yeah. So that if you wanted to consume the service, you would just, whatever language you're in, you would go get, or you would pip install, or, whatever, the client stub for this service. And then you would have code and that code was quite thick in the first instance because the company didn't have a service mesh. And the idea was we could just shave it off, make it thin, nobody would know, and the service mesh would then start doing the retries and the timeouts and that kind of stuff. And the really nice thing that came off the back end that I hadn't heard of anybody doing before was when you wanted to make a break, so we did Semver on the APIs, you wanted to make a breaking change, you had to call it API v2, so your package would then get a major version number bump.
Oh, interesting. Yeah.
And the consumers would have to take that major, Dependabot wouldn't PR it for them. Consumers would have to take that version bump. So we could then use the security apparatus we had in place, the dependency stuff, to say, I want to deprecate v1 of my API. Who's using it? And you don't have to sniff network traffic because we had this. This is a financial institution, right? So you often, a lot of stuff would only run once a year for end of year reporting. So it wasn't safe to know whether version 1 was not being called until you've given it 12 months of literally sniffing all the packages.
That's really
so be like, does anybody still consume v1 of this client stub package? Okay, I'll go talk to them. Nice. So I built all that machine. And I thought this was common knowledge. I thought, they haven't done it yet because they just had other engineering priorities. And I kind of sat down with one of the engineering directors one day and explained this, and they were like, that would be such a big lever to pull. So, it's really cool. I love that kind of stuff. I think it's such a great developer experience. I think that is platform engineering, even though it's not a server. It's really it's dev enablement or whatever you want to call it.
I do the dev enablement. I think people sort of mash the two topics together, developer experience, dev enablement. And again, to the point earlier on we made, people have been doing these things for time, but now we're putting sort of labels on it. I think what you said there is it's solid architecture principles, good team enablement, but people don't always take that bigger picture, do they? My team's doing okay, or whether my team is a operational team or a service team, they're thinking locally. But I think what you said there, Matt, is you've definitely taken that global perspective, right? Consumer-driven contracts or contract-based testing, you've taken that step back. And I think that's something that, unless you've been there before, or worked as a contractor or a consultant where you've pattern matched, you don't always see the need to do that. And that's why I think that, as a contractor or a consultant, that's obvious, common knowledge. Yeah, right. But when you're in your own little world, and you worked there for 10 years, you know what I mean? You haven't poked your head up because you've been so busy. That's suddenly someone else coming in with these new ideas, oh, wow, that's revolutionary, right?
But it's super, again, we don't want to be, say sort of, 1% is an elitist thing. How do folks keep up with this? How do folks get themselves armed with, because you can't know everything. I certainly don't know everything. How do folks get themselves armed with these good ideas?
By the book, obviously.
I was going to say, by the book. So, read the good books. Again, won't offer opinions, but there's certain publishers who have a fairly high barrier for entry. Go to conferences or watch the videos. What would you add? I've done the easy ones. What would you?
Yeah, I think it is carving out time to learn, isn't it? And that's what, because I was the second book, I was thinking, do we write a book? Do people read books these days? Because that's how I literally learned Java was from a book, right? Yeah. Back in the day, back 20 years ago. And now, some of the folks I'm mentoring, the younger generation, they're I watch, videos on YouTube or Pluralsight or, Udemy, whatever, take your pick. Do people still read books? But a good chunk of folks, particularly what I call or Gene Yang calls the 99% folks, people getting stuff done, right? To your point, they're almost too busy to go to conferences sometimes, exactly. Right? So by jumping on YouTube, GOTO have got a fantastic channel as an example, right? Of short form content, long form content, carving out a lunch and learn once a week or putting some time aside to watch these things, read the books, because to your point, they're generally higher quality editorial content. like you just have to make time, right?
Yeah.
And then InfoQ is a good place. Like if you want sort of signposts, jumping off points, the new stack's pretty good. Some other sites out there as well. Like sort of just keeps you common and keeps you like, you keep seeing this like word all the time, like consumer-driven contracts or Wasm. Like you don't have to be an expert, but just have a little look at it. Like, oh, actually, this consumer-driven contract thing, like we've been trying to do this, but we didn't know it was a
that's
thing.
the name for it.
Exactly.
Yeah, right. And now I know what to punch into Google to find the state of the art.
That's it.
Yeah, I think, and actually the ThoughtWorks Tech Radar takes a lot of the effort of that out of you.
Yeah.
Have a look at the terms.
That's a great shout.
If you don't recognize one. And so I think it's about being T-shaped, right? So how do I go, how do I know a little bit about everything so I know whether that's maybe the right solution to look at? Yeah, the conference talk videos, shorts, YouTube channel. I'll shout out my friend Dave, Dave Flanagan, his YouTube channel, but there's fantastic stuff, but there's loads of it. And then if something does become your day job, if you do need to dive in, I feel like we've fucked ourselves so much, right? I've done some LinkedIn learning courses, Udemy and whatever, or a book, right? And then I think you need to know a broad set of things. And as you say,
I agree.
With time, you've also seen them all before and go, oh, Kubernetes, that's just Erlang. But to sort of know the patterns and to match them. And you can do that without being a consultant and seeing, 1,000 businesses over 10 years. And then you can dive in, I think, through.
That's it.
Through going to a particular conference on a particular subject. My first KubeCon was literally, we've heard of this Kubernetes thing. Hey, Matt, work out whether this is the right thing to use at this company. And I just went to the first one.
So many folks did that.
And it was so small. It just felt like a meetup. I ended up going up to sort of Tim Hocking and being like, excuse me, can you explain this part of the system so I know whether I should use it? And the rest is history with my career, because I was like, actually, I like this so much. I'm going to leave my software engineering job. I want this to be my full-time gig, not my side gig. I'm actually going to leave my software engineering job and come do this full time. But for most folks, it's a tool. You get, you understand it, you get it done, you move on, and you keep doing
but the opportunities
what your passion is.
Sometimes,
sometimes the opportunities present themselves. I mean, this is an anecdote from me. I don't want folks to overfit to that kind of story, but as an example of I want to dive into that, there are materials available. Cool. So I think we're being told to move on. I just heard a round of applause for the talk in the next room. The mics might have put that up as well. But no, that was fascinating, Daniel. Thanks very much.
Thanks for to chat, Matt. It's always good to chat to you. Now we've got it on camera. We shared some of our knowledge as well.
Exactly.
Good, right?
I learned a bunch of stuff. I'm going to go and rewatch this, honestly, and re-listen to all the things that that you said, because I was trying to think of what I was going to say next. I'm going to re-listen to all the stuff that you were trying to teach me. So no, thank you very much. It was a pleasure.
Appreciate it.
Thanks.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.